Hello, today we are looking at graphs and we're going to look at a pretty complicated example. We're going to use a graphing calculator to help us create a good graph for this particular problem. Our problem is a retirement annuity, and for an annuity, P is the dollars to invest, and our formula down here, that is what we're calculating. How much should we invest? M is the dollars you want to withdraw each month. R is the interest rate for month. T, number of monthly withdrawals. For our problem, we're to use M is 200, so that means we would withdraw $200 a month. And the value for R that we'll use is 0.01, so that is our monthly interest rate. The first question that we're asked to do with this problem is to use function notation to write a formula for P, your initial investment, as a function of T, the number of monthly withdrawals. So this is practicing. My function notation has nothing to do with graphing yet, but P is a function of T. So P of T, how much should I invest, that principal based on time, equals, and now I'm going to fill in these numbers. So M is 200, and then we're going to multiply that by 1 over R, and we're told R is 0.01, and then we're multiplying that by a huge parenthesis here. In our parenthesis we have 1 subtract, and then we have a large fraction bar where we have 1. In the denominator here, 1 plus R, and so 1 plus 0.01. All of that is to the T power. T is our variable that we don't know, so we keep a T there, and then we end our parenthesis. So this is my function. The principal based on time. I filled in the value for the monthly withdrawal, the value for the monthly interest rate, and the thing I do not know is the number of monthly withdrawals. Next, it asks us to create a graph of your function. Be sure that your graph shows up through 40 years of withdrawals. So, before I go to the calculator, which is going to help me create this graph, I always want to start out with what I already know. My input variable is time. My input variable is always in this parentheses, and it always goes on the horizontal axis. My time here is measured in months. And I know that because everything up here is talking about monthly withdrawals, monthly interest rate, all of that. So, in the prompt for this question, it says 40 years. So I literally want to take that times 12, because there are 12 months to a year. And that gives me 480. And so that is telling me that my x-axis here is to go from 0 out to 480. And so that gave me a lot of information about what I need to graph, what picture to get on my calculator. Now, since time is this axis, the other axis is the P. P here is dollars to invest. So this axis is P, and P is dollars to invest. And I don't have a real good sense. I feel like if I'm going to take out $200 a month, I probably need to invest a good bit in this account, but I don't actually know how much I'm supposed to invest. And that's where I'm going to use my calculator to help me with this. So now I do have this formula written down on my paper, and that's important because I want to go to my calculator and type that into my calculator. So give me a moment to get there. So here I am at my calculator. On my calculator, I want to go to y equals because I want my calculator to work with a formula, not to do just one math calculation. So I go to y equals, and here is where I want to type this formula. So I have 200 times, and then I have the fraction 1 divided by 0.01, and then I have times, I have that huge parenthesis, I have 1 minus, and then I have the fraction, and so I'm going to type my numerator, divided by, and then there were parentheses here, 1 plus 0.01, and then this part that's in parentheses was raised to the t power. And we've talked about before that our calculator only has the variable x, so I put x there, and then I have to either end my parentheses or leave my exponent space, and then that was the end of that huge fraction. So I've typed in my whole formula, including a variable, so that my calculator is working with the formula. Now, we had figured out that we needed a graph that went up to 480 withdrawals. So the next thing I want to do is go to my table, because my table is going to help me understand the size of my graph. So whenever we use table, we first have to set it up. So I want to go to my table setup. Starting at 0 is fine. But I don't want to look at 480 different values. So let's change by 20. Okay? And that really is, I'm just picking something that 480 divides evenly by. And so I'm going to go to my table. So if I want to withdraw, 0 withdrawals, 0 goes in. And so you can start to see how big the numbers are. If I want 200 withdrawals, I need 17,000 and some dollars in there. And I'm going to use my arrow key to scroll down. And my graph is supposed to show up to 480. So I'm having to scroll a good bit, even though I had set this up to go by 20s. So for 480, I would need $19,831 in that account. And so I'm going to make that just a rounded off number, approximately 20,000. So I'm going to go back to my PowerPoint for a moment and show you how this matters. So this axis, the horizontal axis of time, we knew it was supposed to go up to 480. The vertical axis of principal, the amount to invest, we just saw that that needs to go up to approximately 20,000. And I want to make this decision on how big my graph needs to be before I actually try to graph it in my graphing calculator. So 480 on the x-axis, 20,000 on the y-axis. So if I go back to my calculator, I'm ready to graph. But just like we had to set up the table, we have to set up the graph as well. And so the way that we do that is we use the window button, and it will give us a window, a picture of the graph. So in window, my x-axis, which was my horizontal axis, should start at 0, arrowing down, and go up to 480. That's what we had decided. My y-axis, also starting at 0, and it should go up to 20,000. And I figured that out using the table, which is vitally important. Now that I know this, I hit graph, and my graphing calculator draws me a gorgeous picture of this graph. So I can go back to my PowerPoint slide and I can put this picture on my slide. So this ends up being a nice smooth curve. It comes up for a while and then it really tended to level off. And mine's not quite perfect there, but basic idea. So when you provide a graph for me, the axis should be labeled. I should have these maximum amounts figured out from the context of the problem and the table on the graphing calculator, and then I can sketch my picture. So I have done this first one, function notation. I've done the second one, created a great graph. Next, it asks me some questions, and my calculator will answer these for me. How much would you need to invest if you plan for 4 years of withdrawals? Well, we said that the withdrawals are in months, so I have to multiply by 12. And so I'm looking at 48. I'm going to look at the next question while I'm here. And this asks for 10 years, and again, we said this is in months, so I have to look at multiplying by 12, and I have 120. So I want to know how much to invest for 48 years, or 48 withdrawals, and for 120 withdrawals. So on my calculator, we have lots of things that our calculator will calculate based on this formula, and I see the calculate right here above the trace button. So I use my second to get there, calculate, and I want it to calculate a value. So I hit enter for option 1, and I want to know what about when x is 48 withdrawals. So I type 48, hit enter, and it tells me I would need to invest $7,594.79. The other question that I had is what about 120? So again, I use second and I use the trace button to get to the calculate menu. I want to calculate a value. So I hit enter and I type in 120 and I hit enter. And if I want 120 withdrawals, I need to invest $13,940.10. So both of those answers I get directly from my calculator using the second and the trace to get to the calculate menu. So second, trace, calculate, and asking it to calculate a value for me. Now going back to our PowerPoint slide, the last question tells us a perpetuity is an annuity that allows for infinite withdrawals. How much do you need to invest to create a perpetuity? So when I take a look at the graph, I see that the graph is coming up here and then it is leveling off. And so a perpetuity is what is that glass ceiling that this graph comes up against. So my glass ceiling appears to be about here, and I should have a perfectly horizontal line, but I didn't get it quite straight. So this graph obviously comes up and it comes against this line, and I want to know where is that line? What is that amount that if I put something in this account, I can always withdraw? The interest will cover the withdrawals. So if I go to my calculator, on my calculator, I want to look in the table. So I'm going second and the graph button to get to the table. And we can see here that by 480, it's getting close to 20,000. We had rounded that up to 20,000. If I continue to scroll down, I can see it continues to get closer to 20,000. But what I really want to know, does it ever go above 20,000, or is that glass ceiling, that maximum amount? So in my table setup, second window, I can start my table at a really high value. So let's start it at 2,000. All right, let's look at our table. And we can see here that it clearly has reached 20,000 and it stays at 20,000. Now if I arrow over there, I get that it has more and more nines in that decimal, but rounded off $20,000. So the amount for a perpetuity, that amount where the graph levels off, is the $20,000 mark. And so we used our calculator to answer these questions once we created a graph using the table.